Hello, good evening students. Welcome to BYJU'S exam prep. Very good evening all of you. I welcome you all to this live session of a very interesting segment from the industrial engineering that is all about crashing from CPM. Now many students do had difficulty and many students do texted me about, sir, please do make a video on the topic of crashing in the critical path method. So here I am with a very interesting segment. So before starting the this particular segment, please do let me know whether my audio and video is all good and all perfect so that we can start off the session. Hardly it will be taking like 20, 25 or 30 minutes will be the duration of the session. And in this session will be understanding the logic behind why we are doing this crashing, what is the meaning of this crashing, why we are doing this crashing operation, and also we'll be taking one numerical from the same segment so that entire revision will be completed. Okay, so once again I welcome you all to this live session on the industrial engineering all about crashing in CPM method. So before starting the session, I hope so everyone has connected with me on my Telegram channel, and also you can drop me a mail if you have any difficulty or doubt regarding the subject or regarding any technical suggestions. And definitely tomorrow, that is 27th of June, Richa ma'am will be coming up live at 7:30. So do join this free live interactive workshop where she will be discussing about the strategy to be in the top 1% in the GATE 2021. And why this is important, because many students do have doubts on how to be in the top rankers, what I should be doing something different from other students, because it's all about competition, right? You have to have slight different approach in order to get into that top ranker. So definitely she'll gonna, because she has trained, mentored many different students to be in the top ranker. So definitely definitely she will be giving you insight about the strategy to be in the top 1% in the GATE 2024. Good book for industrial engineering conventional questions. I would rather say if you go for OP Khanna and this one, the second textbook, right? That is your, because usually we don't prefer textbook for industrial engineering, whatever we are studied. And if you see yesterday from industrial engineering, there was only one question from inventory, and that too from basic EOQ model. So definitely if you have the basic concept, you can easily solve any kind of question that is being asked. Okay, fine. So, and definitely if you want to register this particular workshop, the link is in the description box. Do register yourself in this. Right, TPM, good evening. Definitely if you want to blindly follow some textbooks, if you can go for OP Khanna. There are some we can say solved examples which you can prefer in practicing the conventional problem, right? And one more textbook for OR, like there are two textbooks, one is for IE, right, and second is your OR. So you can proceed for anyone. It's basically from Khanna Publications, I do remember. Yes, you can go for that. If you see UPSC, IAS also, like many aspirants, civil service aspirants, they are also taking the mechanical subjects. So there also you can do see some previous year question, but I would rather suggest you to be working on your concepts and try to solve the previous year 5 conventional paper questions, because that will be more than sufficient for industrial engineering. I'm not talking about the other subject, but yes, for industrial engineering, more than sufficient, because nowadays the question is being very straightforward, and the best part is in industrial engineering you are getting the numerical oriented questions. Okay, so that's the best benefit of the subject, right? Okay, so shall we begin? Yes. Now, the question is, what do you mean by this word crashing in CPM? Now, all of you know how to draw the network diagram, what is critical path, and how we can identify it's the longest time taking path duration in the network diagram, right? But the question is, why we are preferring this crashing, and why this is, we are calling it as crashing. We could have used some other terminology, right? And what's the concept behind this crashing? Let us talk about that. Now, crashing is basically what we are doing is, let us take one example. Let us suppose there is a job, let's say it is taking 5 days to complete. Okay, there is a job, let's say any X job, and it takes 5 days to complete, and there are 3 workers which is basically being working on this job X, trying to complete in 5 days. Now, let us suppose if I increase the number of person from 3 to, let us suppose, 5, right? From 3 to 5. So can you tell me will the number of days to complete this particular activity will gonna increase or decrease? Simple question. Initially, 3 persons were working and it was taking 5 days. So it is quite sure that if 5 persons are working, so definitely is gonna the duration of that activity completion time will be decreased, right? Let us suppose it is being completing in 3 days. Okay, it is being completing in 3 days. Now, what has happened is we have crashed our duration of activity. This we call it as crashing. Okay, the decrement of the completion time of an activity, we call it as crashing. So what we have did, we have crashed our activity by 2 days. Initially it was completing in 5 days. Now we are completing this in 3 days, but at the expense of what? At the expense of some cost being associated. Initially I need to pay salary of 3 workers, and also let's suppose there was only one machine being used, but now I'm using two machines and 5 workers, so definitely the cost associated with this is gonna increase, right? Okay, but tell me one thing. Let us suppose you might have seen that, you might have heard about like daily allowance. Have you heard about this term, daily allowance? Like if you are in some examinations, they are giving TADA, like they'll be giving you traveling allowance, and they'll be giving some very rare examiners, they'll be giving you the daily allowance also. Like let us suppose you are going from one place to another place, right? And for one day, they're going to give you, let's say 500 rupees for the daily usage, like whatever we are expending, like the expenditure for the daily consumables like food or traveling, etc. Right? Exactly. Fine. So we call it as like every day they're gonna pay me 500 rupees. So if I'm gonna stay for 2 days, they're gonna pay 1000 rupees. If I'm gonna stay for 4 days, they're gonna give me 2000 rupees, 500 rupees per day basis. So over here, if you try to visualize, I'm giving a daily total daily cost that is being I have to pay for the miscellaneous cost that could be. Let's say this is 100 rupees per day. Okay, so initially these persons who are working for 5 days, I have to pay a miscellaneous charges of 500 rupees, but now as this activity is being completing in 3 days, so I have to pay 300 rupees only, right? So there are two aspects of cost in the crashing. There are two different aspects of cost. Let us try to understand that what are the different types of costs being associated, and after that we'll be taking up one numerical. Okay, now it is being quite sure that crashing of any project or crashing of any activity basically deal with two basic approach. One is from monetary aspect, second is from time aspect, right? If I want to complete this particular activity in 3 days, definitely there will be some cost will be increased, right? The duration of time will be decreased. But if I try to decrease the value of this time duration, let us suppose I'm increasing this manpower from 3 to 12. Okay, 3 persons to 12 person, and I'll be completing this in 1 day or even in half a day. But by doing so, you're gonna increase the cost being associated in completing that activity will be too high, right? So we always need to make a balance between the total time taken to complete that activity and the total cost associated with it. There will always be an optimized value, because one of the costs is going to increase. Like if I talk about the cost associated with the salary, with the machine cost, it's going to increase, right? If you're going from 5 to 3 days. But if I talk about the daily cost, per day cost, it's going to decrease. So I need to see, by decreasing the duration of an activity, what is the impact on the total cost. Okay, because total cost will be the summation of two different costs, right? And that two different costs that we need to understand is the direct cost and the indirect cost. Like in any crashing model, we are always coming across two different types of costs, that is direct and indirect. Let us talk about this, then I'll be coming back to that same example and you'll be having a clear cut clarity about the crashing model. Now the question is, what is direct cost? Now let us suppose initially the same example, there was a machine, right? And there were 3 persons working on that machine, and it was taking, let's say, 5 days to complete this particular activity, right? Now what has happened, I have taken one more additional machine we have taken, and now approximately 6 persons are working in this particular activity, right? So definitely from 5 days it will be crashed down. Let us suppose it is crashed down to 2 days. Okay, so we are decreasing the time duration of this activity by 3 days. I am decreasing the activity completion time by 3 days. So the cost which is basically increasing with the crashing of the activity, that cost we call it as a direct cost. The cost which is being associated while decreasing the duration of an activity, it could be the salary of the employee, it could be the rent expenditure, like okay, it could be your the electricity bill. Initially we were only using one machine, now we are using two different machines, I have to pay the rent for the two different machines, the electricity bill will be more. Okay, so the cost which is being associated while decreasing, while crashing any activity, the cost that is increasing, we call it as direct cost. That means it includes the direct labor, it includes the raw material cost, includes the manufacturing supply. Okay, so whatever expense that directly go into producing the goods or providing the service, that cost we call it a direct cost. That means if you try to alter the number of days, whatever cost is being required in order to complete that particular activity directly, right? It is we can say the raw material charges, the lubrication, the spare parts charges, your we can say daily wages, okay, the electricity bills. So these are the different costs that is being included, that is coming under the direct cost. But if I talk about the indirect cost basically let us suppose in one day you are manufacturing, let's suppose there is a we can say let's talk about from production aspect. Let us suppose there is a machine, right, and in that machine I am manufacturing 10 units on one day. Another second day I'm manufacturing 100 units, right? So it's gonna my rent of that machine is gonna alter according to the manufacturing. Like so on one day I'm manufacturing only 10 units, okay, and on the second day I'm manufacturing 100 units. So is the rent of that machine is gonna change? It's not gonna change, right? It's not gonna change. So I can say indirect cost is basically that cost which is being associated in timely and safely completion of an activity. Okay, it is not directly being impacted, but yes, it is also one of the important component for completing an activity. The best example is your let's say the safety helmets. Okay, the safety cost. Let's suppose the stationery cost, like if the documentation, the files, this is not important for the timely, we can say directly affecting our production rate, but yes, it is also an important component for completing any activity. So indirect cost is basically the general business expenses that keep you operating. Let's like we can have rent, utilities, general expenses okay, just like your per day cost, just like we can say the per day cost, right? Okay, so for having more clarity, now let us talk about the direct cost in detail, because this is the cost which is gonna increase. Okay, because if crashing is done, if crashing is performed, right, if the crashing is performed, then the direct cost is always gonna increase, and the indirect cost is always gonna decrease. Okay, yes, if I say if you are doing crashing, the direct cost is always gonna increase and the indirect cost is always gonna decrease. That is quite sure, right? Okay, now if I talk about direct cost, because as you are decreasing the time, the cost is increasing. So if I try to plot a curve, between cost versus time. Okay, let us suppose when we are completing in a normal, like I'm not doing any crashing, the 5 days for completing that activity. So normal time, this is your normal time, right? And corresponding to normal time will be having a normal cost, right? Corresponding to normal time will be having a normal cost. Okay, but let us suppose if I'm decreasing the activity duration, I'm crashing that activity from Tn to some value like Tc, right? I'm decreasing that duration. So definitely the cost associated with that crashing will be more. So this is the crashing cost, that is Cc, right? So technically, if you try to visualize, if I try to if I try to connect this, we can have various n number of points. If I try to make it, will be a curve. It will be a curve like structure. It won't be a straight line. But one assumption that we are doing is, because the variation will be almost linear, So we are assuming this to be a linear approximation. We are assuming there is a linear approximation or linear changes being made whenever I'm talking about the direct cost with respect to time, where CC represents the crash cost, your N represent the normal cost, Tn represents the normal time to complete an activity, and Tc represents the crash time to complete that activity. Okay, fine. Is this clear? So we are doing some linear approximation. Actually, the curve will be something like this. This will be the actual curve, but we are going for some linear approximation so that we are able to get some result which is much more appropriate. Okay, so can you tell me, if I try to calculate the slope of this curve, if I want to calculate the slope of this curve, that will be the change in cost by change in time. So that will be equal to the crash cost minus the normal cost divided by the normal time minus the crash time. Okay, so this is the most important element in order to do crashing. In crashing, the cost time slope, we call this slope as the cost time slope. Okay, so cost time slope plays a very vital role in order to do crashing, because there will be multiple activities in a project. Let us suppose there are 10 to 15 activities. So the question is, which activity will be crashing? You'll be saying, sir, very simple, it will be critical activity. So it is not having only one critical activity, it will be having combination of different critical activities. So among different critical activities, which critical activity you need to crash in order to have more optimized value? So that's the reason we are calculating the cost time slope. What is the meaning of this cost time slope? Let us take one example. Let us suppose for an activity A, your normal cost is rupees, let's suppose 2000. Okay, fine, let's say 1000. Let's say the normal cost is 1000 and the normal time to complete this activity is 10 days, right? And let us suppose the crash cost is near about 2400. Okay, rupees 2400, and the crash time is let us suppose 14. So let us go for 3 days. 3 days, right? Let us suppose this is the data for any activity A. Now let us try to calculate the cost time slope. Let us try to calculate the cost time slope, right? That is your delta C by delta T. So it will be 2400 minus 1000 divided by 10 minus, this is crash cost, 10 minus 3. So this will be 1400 by 7, that is equal to 200. What is the meaning of this word? The meaning of this word is, I have to pay additionally 200 rupees per day in order to decrease the activity by 1 day. Let us take one example. Initially, when you are completing this activity in 10 days, when you are completing this activity in 10 days, it's gonna cost me how much? It's gonna cost me 1000 rupees. It's gonna cost me 1000. If I want to complete this activity in 8 days, let us take an example. So can you tell me what will be the additional cost? Sir, it will be costing me 1000 plus per day your cost, that will be increased by 200 rupees. So we are crashing down by 2 days. So 2 into 200. So it's gonna cost me 1400 rupees. If I'm completing this activity instead of 10 days, and if I'm completing in 8 days, it's gonna cost me approximately 1400 rupees. Clear? Fine. Let us take one more example. Let us suppose I'm crashing down to 5 days. If I crash down to 5 days, what will be the total cost associated? This is a direct cost. This all I'm doing is the direct cost. So all this calculation that we are doing is for the direct cost, not about the indirect cost. Okay. So what is the duration of time that has been decreased? That is 1000 plus 5 into 200. So it will be costing me rupees 2000 in total. If I complete this particular activity in 5 days, it's going to cost me rupees 2000. Let us suppose I am completing this activity in 3 days. if I complete this activity in 3 days, it will be 1000 plus 7 into 200. So it's gonna cost me rupees 2400. And I think so this is the same value that we are getting in, if I want to complete this activity in 3 days, it's gonna cost me 2400. Okay, so this is about the direct cost that we have seen in detail about in the crashing. And it's very important, in before doing the crashing, you should be having complete knowledge about crashing and its cost. Okay, fine. Is this clear? Right. Can we proceed now? One second. Yes, sir. Okay. Chaliye, let's proceed now and talk about the next one, right? The next one, that is the indirect cost. Okay. Now in indirect cost, let us suppose I'm taking the same example. Let us suppose for this activity A, the indirect cost which is given is rupees 300 per day. It's gonna cost me 300 rupees per day. So initially when I was completing in 10 days, it's gonna cost me how much indirect cost? The indirect cost will be equal to 3000 rupees. 300 into 10, that is rupees 3000. Right? But if I want to complete this in 5 days, right, it's gonna cost me, indirect cost will be equal to rupees 1500. So are you able to see this, what has happened? By doing crashing, your direct cost is going to increase. Like if you try to compare the 5 days completion, the direct cost is increased by 1000 rupees, but the indirect cost is decreased by how much? 1500. So we are having a benefit of 500 rupees. If you try to visualize, in 5 days, when you are crashing till 5 days, your direct cost has increased from 1000 to 2000. Right? If you see, initially it was 1000, but it has now increased to 2000 rupees. But the indirect cost has decreased from 3000 rupees to 1500. So can we say what's the net saving that we're having here? We're having a 1000 rupees increment. Here we're having 1500 decrement. So overall, can we say there's a total 500 rupees of decrement? That means I have completed this activity in 5 days and I have to pay 500 rupees less. That's the best thing. That's the best thing that has happened in crashing. Because initially students having a perception that, sir, crashing matlab cost increase. No, it's not like this. Crashing doesn't mean that cost, yes, definitely the direct cost is going to increase, the indirect cost is going to decrease. So I have to identify a point at which your costs will be optimized, because the total cost, what is the total cost? Total cost is always the summation of the direct cost and indirect cost. Total cost is basically the summation of direct and indirect cost. So that is the reason we need to see what will be the optimized way to calculate the total cost, because while doing the crashing, indirect cost is going to increase, indirect cost going to decrease. So I have to find an optimum value at which the total cost will be minimum. Is this clear? Understood? Fine. And this particular crashing is basically also known as, this crashing model also known as your time cost trade-off overview. Okay, time cost trade-off model, because when the project duration can be reduced by assigning more number of resources, and how we can do, because when we are doing this crashing activity, the project cost is going to increase. This is basically, I'm talking about the direct cost. Okay, fine. So always remember that whenever we are doing crashing, the direct cost is going to increase, the indirect cost is going to decrease, right? Okay, chalo. So now let us take one example, because without example you won't be having much clarity about this particular segment. So let us say the first example. A project has 4 activities P, Q, R, S as shown in the figure, and the normal cost of the project is 10,000. So have given this as the direct cost, that is a normal direct cost. This is the direct cost which is given without crashing, and the overhead cost is rupees 200 per day. That means we are having an indirect cost of 200 rupees per day, right? If the project duration has to be crashed down to 9 days, what will be the total cost? What will be the total cost? So first of all, draw the network diagram. Okay, so they have given some predecessor table, right? And there's some given the duration also. So we are having P as an independent. So let me draw it over here. This is 1, 2, 2. This is activity P. Now activity P having a predecessor, or we can Q and R having a predecessor of P only, and R. So this is your R and this is your Q. This is Q, and S is having a predecessor of R. So this is R. Okay. So 1, 2, 3 and 4. So you have completed the network diagram. Let us write the time duration. So P is having 3, Q is having 7, R is having 4 and S is having 5. So this is the we can say the total network diagram. First of all, tell me what will be the your critical path. Quickly tell me what will be the critical path. Quickly. You have the network diagram. You have drawn the network diagram. Next, the next second step is identify the critical path. Chalo, let's see. 0, 0 plus 3 is 3, 3 plus 4 is 7, 7 plus 5 is 12, and 3 plus 7 is 10, right? So we'll be having 12. So the critical path will be 1, 2, 2, 3, and 3, 4. Okay, the critical path is basically we are having is 1, 2, 3, 4. That is P, R, and S. Basically, we are having this as P, R, and S, right? Okay, so I'm not doing any crashing at present. Let us try to calculate what's the total cost. In the problem, it is not required. They're saying that you have to crash down to 9 days, but for more understanding, let us try to calculate the total cost if you are completing this activity in 12 days. Okay, so we can say total cost. Let us try to calculate total cost. That is equal to summation of direct cost plus indirect cost. Okay, what is direct cost? Direct cost is 10,000, 1, 2, 3, 4, plus indirect cost is 200 rupees per day. So 200 into 12. So in total, it will be 12,400 rupees. Is that so? So normally, it's gonna take 12,400 rupees when you are completing this entire project in 12 days. But we have to complete in 9 days. Chaliye. Now let's do some crashing. Now, in this problem, they have already given you the cost time slope. They have given this, the cost slope they have already given. In some problems, they won't be giving you, you have to calculate individually for individual activities. But in this problem, they have already given, so our effort is slightly reduced in this. Okay, so now let's do one thing. Let's try to identify which of the activity are critical activity that we have already identified. That is P, R, and S. P, R, S. Okay, so among P, R, and S, S is having the least cost line slope. Because if I try to decrease activity, if I try to crash activity S by 1 day, my project is going to decrease by 1 day because that is a critical activity that we are having. Okay, that means if I try to convert this from 12 to 11 days, my project is gonna cost me additional 200 rupees I have to pay. Okay, chalo, let's do one thing. Let's do crashing. So crashing activity S by 1 day. Basically, it has to be 2 days, but let us take one by one. 1 day. So if I try to crash, now I'll be drawing a new network diagram. I would have used that same only, but let's try to make it more simple. Try to understand in every network diagram. We'll be trying to understand each and everything. Okay. Understanding is important because it's all about concept clarity. The more concept clarity, the more easily you'll be able to solve any variety of questions. Okay, so what we have done is this particular activity is being crashed down by 1 day. That means now we are completing in 4 days. So let's see what is the critical path. So this is 0, this is 3, this is 7, 7 plus 4 is 11. Still the critical path will be same, right? Still the critical path will be same. So again, we'll be identifying the least cost time slope. Again, we'll be having S. So can we directly crash this activity S by 1 more day? That is 2 days. Let us go for that. So if you try to crash activity S by 2 days, so now you are having the updated network diagram will be something like this. Okay, now it will be 3 plus 7, 7 plus 3 is 10, and this is 3 plus 7 is 10. So in this case, each and every activity is a critical path, because we are having two critical paths. One is P, R, S, and second is P, Q. These are the two critical paths. These are the two critical paths which we have obtained in this particular network diagram. That is PQ, 10 is the duration, and PRS, the second critical path. Okay, so now I have to crash, sir, it will be having, now Q is also a critical activity. So we have to crash activity Q by 1 day. Okay, so let me redraw this diagram. 1, 2. In examination, no need to draw the diagram again and again. It's only for understanding, for make you understand. I'm drawing it again and again. In examination, not required. Okay, so this is P, Q, R, S. This is 3, this is 7, this is 4, this is 3. Okay, and what we are having is, we are having this as the critical path, this as the critical path, this as the critical path, and this as the critical path. Okay, so total duration is 10. Now, according to this table, we have to crash activity Q by 1 day. We have to crash activity Q by 1 day. Okay, we have to crash activity Q by 1 day. If you try to crash activity Q by 1 day, then what will happen? Is my critical path changing? Yes. And is my duration of completion of the project is changing? Let's say I'm changing this to 6. I'm crashing by 1 day. So now let's try to see what will be the critical path. Okay. So we'll be having 0, 0 plus 3 is 3, 3 plus 4 is 7, 3 plus 6 is 9, 7 plus 3 is 10. Now, by doing this, what has happened? My project duration has not changed. It is still 10 days. Now, we'll be saying, sir, why? Because here we are having two critical paths. One critical path was PQ, second critical path was PRS. So, in order to decrease this duration of project by 1 day, I have to select both the activities in both the path. Okay, if I'm selecting Q, so among P, R, and S, S is having the least one. Let us crash activity S by 1 day. Now, if I try to visualize, now it has changed to 2. So now it says 0 plus 3, 3 plus 7, 7 plus 2 is 9, 3 plus is 9. So we are having the duration of the project has been decreased to 9 days. Okay. But is there any other possibility, like instead of crashing, because for crashing Q by 1 day, it's going to cost me 100 rupees. Okay. It's going to cost me rupees 100. And for crashing activities by 1 day, it's going to cost me rupees 200. Okay. So total cost will be 300 rupees per day will be required in order to move from 10 to 9 days. Yes. Is there any other possibility? Let's take one more possibility. As you see that activity P is common for both the pathway. Activity P is common for both the pathway. So can I say if I crash activity P by 1 day, if I crash activity P by 1 day, because it is common for both the critical path, my project duration will be changed from 10 to 9. Let us see. Let us see whether it is changing or not. If I try to change activity P by 1 day, so this will be equal to 0 plus 2 is 2, 2 plus 7 is 9, 2 plus 4 is 6, and 6 plus 3 is 9. Sir, perfect. Instead of crashing two activities, my problem is solved by crashing only one activity. Let us see what is the cost associated in crashing activity P. Activity P ko crash karenge, it is costing me 500 rupees. It is costing me 500 rupees. Yes, but combination of Q and S will be costing me 300. So ideally, I'll be selecting this method or this particular pathway, not this one. So now I can say in order to reach from 12 days to 9 days, the project completes from 12 days to 9 days, what we have to do, we have to crash activity S by 2 days. Okay, you have to crash activity S by 2 days, right? And you have to crash activity Q and S by one day. You have to crash activity Q and S by 1 day each. Then only you will be able to crash from 12 to 9 days. That means 3 day crashed, 3 day decreased. Okay. So let us see what is the total cost associated. So total cost, what is the total cost? Total cost is gonna equal to direct cost plus indirect cost. What is the direct cost? 10,000 is a normal direct cost plus Now for crashing activity S, now in total can we say the activity S is being crashed by 3 days in total, in totality, and activity Q is crashed by 1 day. Right, 2 plus 1 is 3 and 1. So activity S per day crashing cost is 200. So it will be 200 into 3 plus activity Q crashing cost is 100 rupees. It will be 1 into 100. So this is the total direct cost. Indirect cost will be per day cost is 200. So 200 into, now we are crashed down to 9 days, 200 into 9. Can you tell me what will be the value? 10,000 plus 600 plus 100 plus 1800. What will be the total cost associated? It will be 24, 25. It will be rupees 12,500. Okay, 12,500. Yes. So, okay. So can we say, if I'm moving from 12 days, 12 days में कितना cost है? 12 days में it was costing me 12,400. 12 दिन में प्रोजेक्ट कंप्लीट करते हो, इट गोना कॉस्ट मी 12,400, और यही प्रोजेक्ट जब आप 9 डेज में खत्म करते हो, इट गोना कॉस्ट मी 12,500. ठीक है, 100 रुपीज इंक्रीज हुआ है, राइट. इट इज नॉट ऑप्टिमम वैल्यू, बट यस आई कैन से बाय गिविंग एक्स्ट्रा 100 रुपीज आई एम एबल टू कंप्लीट दिस एक्टिविटी इंस्टेड ऑफ 12 days to 9 days. Okay, one more time. Okay, fine. Let's quickly recap what was the question, because that is very important. Definitely. Initially, there was a complete 4 activities being given, right? Then we have calculated the critical path, and we have seen that, okay, sir, PRS is the 3 critical activities, and without crashing, it's gonna costing me 12,400. This is without crashing. Okay. Now, when I crash activity S by 1 day, my critical path is still remaining the same, that is PRS. So that's the reason I have crashed activity S by 2 days. So when I'm crashing activity S by 2 days, I have changed my project duration from 12 days to 10 days, right? 10 days, right? And after that, I'm not calculating the total cost right now, because I need to crash down this activity, this project by 9 days. So this is done. Now again, I'm trying to calculate the critical path. Now while I'm calculating the critical path for this particular updated value, I'm getting all the activities to be critical path. That means I'm having PQ as one of the critical path and PRS as a second critical. There are 2 critical paths that we are getting, right? So what we have did, so no problem, all the activities are critical activities. Let us identify the activity which is having the least cost slope. So Q is having the least cost slope, right? This Q is having 100 rupees only. So let us crash activity Q by 1 day. So if we crash activity Q by 1 day, let's say this is 6. Okay, let's say this is 6, right? So if I try to only crash activity Q by 1 day, then what will happen? 0 plus 3, 3 plus 6 is 9, 3 plus 4 is 7, 7 plus 3 is 10. Your this one critical path has not changed and the project duration is still 10. That means why this happened? Because there are 2 critical paths. So I have to select, if Q is selected, then among this we have to select one more. So among P, R and S, the least one is 200. Among P, R and S, the least one is of 200. So that is the reason we have crashed activity S by 1 day. So it's gonna cost me 100 plus 200 is 300 rupees in order to go from 10 days to 9 days. So once I'm crashing this activity by this one day, so now my project duration is changed to 3 plus 6 is 9, 3 plus 4 is 7, 7 plus 2 is 9. So my project duration has changed from 12 to 9 days, right? But there is one more feasibility, that if I crash activity P by 1 day, because this is common, my problem will be solved. So if I crash only activity P by 1 day from 3 to 2, it's going to change to 9 days. But by doing so, I need to pay an additional value of 500. Why need to pay? And I need to pay 500. If my problem is being solved by moving from 10 days to 9 days, I have to pay 300 rupees additional by crashing Q and S combinedly. But by crashing only P alone, it's going to change from 10 to 9 days, but it's going to cost me 500 rupees extra. So I won't be doing this. I'll be going for this. So now I can say, I can summarize that when I am going from 12 to 9 days, in total, I have crashed activity S by 2 days and I've crashed activity Q and S collectively 1 day each. So I can say in totality, S has been crashed for 3 days, queue is being crashed by 1 day. So total cost would be direct cost, which is already been given 10,000, plus what we have to pay additional. You have to pay 3 days for S, because 200 rupees per day was the crash cost slope and 100 rupees per day was the cash cost slope. So 200 into 3 plus 100 into 1 plus indirect cost was 200 rupees per day. This is the indirect cost. So 200 into 9, in total it gonna cost me 12,500. Okay, so the final answer to this problem is 12,500 rupees will be the total cost associated in completing this project in 9 days. Clear, Shubham? Okay, fine. But is that optimized value? Yes, this is not an optimized value. This is not an optimized value. Why? Because my cost has increased by 100 days. So can we say if I try to complete this in 10 days, let us see what will be the cost if I try to complete this in 10 days, right? So if I try to complete this in 10 days, let us try to calculate total cost for 10 days completion. Okay, so this is direct plus indirect. This is 10,000. Now to reach 10 days, I have to crash activity S by 2 days. That's it. To reach 10 days, I have to only crash activity S by 2 days. Okay, so S per day cost is 200. So 2 into 200 plus 200 into 100, 200 into 10. Okay, so this will be 10,000 plus 400 plus 2,000. Okay, so it will be rupees 12,400. Can you believe this? That if I am completing this activity in 12 days, the total cost, days mein 2s aa gaya, 1 second. If I am calculating this activity, the total cost is 12,400. And when completing this activity in 10 days, its total cost is again 12,400. So which will be the optimized value? This will be my optimized value. This will be my optimized answer. Okay, but in the question they have talked about 9 days, so we have calculated 9 days, which is 12,500. That is secondary. The problem is solved. But for more discussing, now why this has happened is because the indirect cost. What is indirect cost? Indirect cost is 200 rupees per day, and activity S, the cost slope is 200 rupees per day. Okay, so when I am crashing from 12 days to 10 days, what has happened? Due to this crashing, I have to pay 2 into 200 rupees as a direct cost. That is gonna increase, but by crashing this by 2 days, my indirect cost is being saved by 200 rupees pay. So 2 into 200, this is the total indirect cost that is being decreased. So net change is 0. By 400 increase, 400 decrease. So net change is 0. That is the reason we are getting the same cost for 12 days and for 10 days. Is this clear? So optimized value will be 10 days because in 9 days, it is costing me 12,500. The cost has been increased by 100 rupees. Okay, so this is all about the crashing in critical path method. Please try to solve questions because these kind of question is being repeatedly asked in the GATE examination. Okay, right. So this is it from my side, all about the crashing in our CPM method. And this Saturday, I'll be coming up with a very interesting video. Do watch that. Saturday ko live hoga. Every Saturday we are having this Know the Legend and Raftar videos, right? Apart from this, we are always having scholarship tests. The description is in the link box. And without e-resources, without the resources, the preparation is not complete. So whatever ebooks is being required for preparation, some students has asked me, sir, OP Khanna ka ebook kahan hai, right? Or any other textbook, like we were having your SS Ratan ho gaya, ya PK Nag. So all these ebooks are available in the description. There's a download link where you can download this free ebook. Okay, so that's it from my side. I hope you all enjoyed. So let's connect next day and talk about more about the interesting concept which is required for your GATE and ESE preparation. Okay, so thank you guys. Bye bye. Do take care of yourself, and let's meet in the next session. Till then, enjoy your preparation with BYJU'S exam prep. Thank you guys. Bye bye. Take care.